This is the cellular transport assessment done by William. First, I will talk about the passive transport. Passive transport is the movement of molecules in and out of the body without using energy, as known as adenosine triphosphate or ATP. First up is diffusion. Diffusion is the movement of molecules into and out of the cell without using energy. And there are normal diffusion, where the selectively permeable cell membrane allows the proteins, in this case, go in and out of the cell from higher concentration to lower concentration due to the concentration gradient. And there's the facilitated diffusion, where the molecules, in this case sodium chloride, goes from higher concentration to lower concentration. However, then they use the protein channels since they cannot go through the selectively permeable cell membranes. Next up is osmosis. Osmosis is the diffusion of water molecules, and as you see here, the half circles are the water molecules, and when osmosis takes place, water molecules also flow from higher concentration to lower concentration due to concentration gradient. However, since the cell membrane is selectively permeable, water can go into and out of the cell freely. Next up is the isotonic, hypertonic, and hypotonic solutions. The isotonic, hypertonic, and hypotonic solutions show osmosis and the movement of water based on concentration gradients. First up is the isotonic solution. As you can see, the concentration of molecule both outside the cell and inside the cell are similar. So the movement of water for both the cell and outside of the cell are the same, and their level of water inside them are same. However, in the hypotonic solutions, the cell has more molecules than the water. Therefore, more waters are going into the cell rather than going out, and therefore the cell bulges and getting bigger. And lastly, the hypertonic solution, where there are more molecules outside the cell rather than inside the cell, so the water goes out and making the cell shrivel and minimize in size with less water inside them, so that the concentration of both inside and outside the cell are the same based on concentration gradient and their act of equilibrium. Next up is the active transport. Active transport is the movement of molecules in and out of the cell, just like diffusion. However, they use ATP. First is the sodium-potassium pump. Sodium-potassium pump is a way of cellular transportation using adenosine triphosphate. First, there is the protein pump with the sodium and potassium surrounding it, the pink diamonds being the potassium and yellow squares being the sodium. First, the potassium goes into the protein pump, and there are 3 molecules that go in, and with the help of ATP, they move up and are released. And as they're released, the 2 sodium molecules go into the protein pump, and also with ATP, it is moved into the cell where there are more need of sodium. This doesn't really matter with the concentration gradient since it uses ATP, and this is a way of molecules traveling into and out of the cell, ignoring the concentration gradient. Next is the endocytosis. Endocytosis is engulfing of molecules by cell, and it is a faster way than facilitated diffusion, where they have to go in order and go through the protein channels. However, endocytosis is where the cell engulfs the molecule, and as it engulfs the molecule, it uses ATP. And if the engulfing is finished, then the vacuoles form around the molecules, containing the molecules, and then later distributing it into the cell. Next is the phagocytosis, and this is similar to endocytosis except that the cell engulfs larger molecule that cannot go through diffusion or even protein channels. Like this is a way big molecule, and the cell also engulfs the bigger molecule and completely engulfs it, and also the bigger molecule is surrounded by vacuole if it is completely engulfed, and at the second process ATP is used as the cell moves and covers the bigger molecule. Next is the exocytosis, which is where number 1, the molecules are already inside the cell surrounded with vacuoles, and second, they are pushed outwards and the cell membrane are pushed inwards so that they are finally separated as number 3, and the vacuoles open and the molecules are released, and therefore it's similar to endocytosis, however the complete opposite. And also this uses ATP as the cell membrane move, not on its will but with the commands, and as it moves it uses the energy. Now I'll just summarize the boring things that I've just said. There's 2 parts to the passive transport that doesn't use ATP, are diffusion and osmosis. Facilitated diffusion is also part of passive transport, however it is for molecules that cannot go through the permeable cell membrane and uses the protein channel. Active transport is the movement of molecules using ATP for the cell to consume the molecules or let the molecules out of the cell.